For example 1, we're going to find the 6 trig ratios of alpha. And so I'm going to tell you what the basic trig functions are and just go over that so they're kind of sitting here as we do our example. Sine is defined as the opposite side over the hypotenuse. Cosine from an angle is defined as the adjacent over the hypotenuse, and then tangent's defined as the opposite over adjacent. And that is something that you've learned in geometry class. You probably heard it called SOHCAHTOA, and that's just a little acronym that helps you remember those first basic ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. There's also 3 reciprocal functions that you may not have learned in geometry class, and those are cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, and that's h over o. So you just kind of flip the fraction. It's the reciprocal of the fraction. Secant is the reciprocal of cosine, so that's h over a. And then cotangent is the reciprocal of tangent, which is a over o. And so there's our 6 basic trig functions that we're going to use to build our ratios up for both of these problems. So I'm going to start with a little assembly line here. The angle that they're telling us to position ourselves at is alpha, and so I'm going to be working at the top here, and I'm going to make a little assembly line. I want to find sine of alpha, cosine of alpha, tangent alpha first, and then once I do that, I'll go ahead and find the other 3 reciprocal function values. The only reason I'm not going to make an assembly line over here and write down cosecant, secant, and cotangent is because I just don't really know how much room I need, and I don't want to squish everything in, so I'm just going to wait for a minute or 2 until we get the first column done. Let's go ahead and label our triangle parts. The hypotenuse is always directly across the right angle, and so you probably know how to do that from geometry class already in the Pythagorean theorem. The opposite side is a side that is directly across your angle that you're positioned at. It's opposite the angle you're positioned at. So the side that's directly across from my angle is the 5, and then the adjacent side is the leftover side that's right next to your angle, which would be the 12. Now if I highlight my angle, I'll just bold it up right here. Okay, so that's my angle highlighted that I'm working off of. You can see that both of the sides highlighted are actually right next to my angle. They actually form the angle, and they're both technically adjacent to my position. However, the 13 is already called the hypotenuse, so you don't have to say adjacent side number 1 and adjacent side number 2. The hypotenuse is already labeled with something. So opposite sides directly across from you, it doesn't really have anything to do with the angle. It doesn't form the angle. It's the farthest away, all the way on the other side of the triangle from your position. The hypotenuse is across the right angle, and the adjacent is that leftover side that's next to you. All right, let's go ahead and start building. Sine is O over H. It's your SO in SOHCAHTOA, and my O over H is 5 over 13. Sometimes I kind of just sound out SOHCAHTOA when I'm building. Sine, cosine, and tangent. I'll think of cosine as ah, like SOHCAHTOA, ka, and I literally look off my triangle and I say ah to myself, and then I can just kind of build that fraction. My A over H is 12 over 13. And then we need tangent, which is oa in SOHCAHTOA, and my oa is 5 over 12. And if that's too goofy for you, then you can just go ahead and say that sine is O over H, cosine's A over H, and tangent is O over A, and then build them. Okay, let's go ahead and do cosecant, secant, and cotangent. I don't always put a little bar down here. I'm just doing that so I can kind of squish my stuff together and leave room for the second example. Okay, so we'll make an assembly line. I have cosecant of alpha, and I have secant positioned at alpha, and cotangent positioned from alpha. Cosecant of alpha is going to be the reciprocal of sine, so as long as I build sine correctly, I can kind of cheat and look off my sine fraction and just flip it, or you can go from the picture and do your h over o. My h over o would be 13 over 5 off the picture, and you get the same thing. My secant is going to be h over a, which is the reciprocal of cosine, is 13 over 12, and then cotangent is AO. It is the reciprocal of tangent, so that's 12 over 5, and that guy is done. There wasn't really much to simplifying any of those fractions. You can leave all your improper fractions improper. You don't have to decimalize anything. Just leave them as is. Okay, let's go ahead to the next problem. Our alpha that we're finding, we're still just finding alpha, is just by coincidence at the top of the triangle again. Not every single problem is going to be labeled the same way. You have to make sure that you label the parts of the triangle based on which acute angle you're at. And I didn't say this yet, but you never, never, never position yourself at the right angle. You never, 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 ever work off of that. You're always going to work off one of the acute angles that are left over. And so if I was down here at the bottom and my alpha was at the bottom of the triangle, then my opposite and my adjacent would end up switching. But by coincidence, the triangle is going to be labeled exactly the same way. The hypotenuse is across the righty. The opposite side is all the way across my angle. So your opposite's again on the bottom, and then your adjacent is the 3. And then we're going to go ahead and make a little assembly line. Sine of alpha, cosine of alpha, and tangent from alpha position. Okay, so sine is O over H. So literally in my head, I'm saying the O to myself. And O over H. Okay, go ahead. Go ahead, Daddy's upstairs. That's okay, just go ahead. Daddy's upstairs, go for it. All right, so where were we? Oh, so 3 root 3 over 6. And then that can be reduced. 3 over 6 can turn into 1/2. And you end up with root 3 over 2. Okay, cosine is it's A over H. So I look at my picture and I spell out to myself, and A over H is 3 over 6. And that can be reduced to 1/2. And then we have tangent, which is OY, so kotowa, and my O over A, my OY is 3 root 3 over 3. And then I can cancel out my 3's. 3 divided by 3 is technically 1, and then 1 times root 3 is just root 3. So I'm going to put a little bar here. I don't always do that just because I'm squishing all my work together. I'm going to put the bar in. So a little separator, and then we'll go ahead and make an assembly line for cosecant, secant, and cotangent. Now if you weren't in class and you didn't see the full blown lesson, I just want to state that you don't pronounce this kisk or sec or cot. It's cosecant, secant, cotangent. You say the full word. And there's sine, cosine, tangent, and then cosecant, secant, and then cotangent. Just FYI. Okay, so cosecant is going to be my H over my O, which is going to be 6 over 3 root 3. Now you can start with that, take your 6 and put it over 3 root 3, but then you're just going to have to clean it up and reduce anyway. So I'm just going to make my life a little bit easier, and I'm going to steal this reduced fraction and then flip it. So cosecant is the reciprocal of sine, and I'm going to flip that 2 or that 3 root 2 and turn it into 2 over root 3, and then we have to rationalize our denominator, and you get 2 root 3 over 3. And if you're like uncertain about that and you just want to start with the original numbers, go ahead. Secant, I can take the 6 and put it over 3. It's the reciprocal of cosine, or I can take the reduced fraction of the reduced fraction of 1/2 and turn it into 2 over 1, which is just 2. And then finally, I can take my tangent ratio and flip it to get 3 over 3 root 3, or I can steal the simplified version, which technically is root 3 over 1, and root 3 over 1 flipped would be 1 over root 3. So we get 1 over root 3, and you got to rationalize. And then you get root 3 over the square root of 9, and the square root of 9 is 3. So that's that example finished.